Hey everyone, today we are going to solve the Daily LeetCode challenge of 10th April 2024 and the problem statement is reveal cards in increasing order. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array deck such that each of its elements represent a card and each of the card has a unique number, okay? And it has been mentioned that all these cards are initially unrevealed. Now what does it mean? So let's say that we are having a total of 7 cards over here, correct? So let's draw these 7 cards. So these are the 7 cards, okay? And each of them has a number written on it, okay? But they are placed in a backward direction. And what does it mean? It means that if they are, let's say that if they are placed on a table, then the side on which the number is written is facing towards the table. That is, we are not able to see it, okay? And how we can see that what is the number written on it? We can flip it to see the number written on it, okay? Now, these all are unrevealed, correct? That is, we are not able to see that what number is written on it, correct? Now, how can we reveal it? So, we can reveal these cards by following these steps, correct? And what are these steps? It says that reveal and remove the top card. So, what does it mean? It means that if this is the first card, then what we can do is we can reveal it. So, we will flip it. And let's say the number written on it is A. So, we are able to see that okay, A is written on it. Okay, after that, what is the second step? We have to place its next card to the end. So what is its next card? Its next card is this one, correct? So what we will do is we will place this card at the end. So we have this card over here, fine. And what is the third step? The third step states that we have to repeat the same until we have some cards left. Okay. Now what we will do? Now since we place this card, we'll move to the next card. That is this one. What we will do? We will reveal this card. So let's say this card has a number written on it. So let's say it's B. Okay. Now since we have revealed this card, what we have to do? We have to place the next card at the end. So this card will move at the end. So we will have it over here. Correct. Now what we have to do? We have to reveal this card. So we will reveal this card. Let's say the number written on it is some arbitrary number C. And what we will do, since we reveal this card, we will place the next card at the end. Correct? So this card will move over here. So what we are doing, we are firstly revealing the card and removing it. Secondly, we are placing the next card to the end. Correct? Now this is the next card. Now what we will do, we will reveal it. Let's say it has D on it. Correct? And we will place this next card at the end. So this will move at the end. And we have to keep following these 3 steps until we have some cards left. Okay. And this is the way how we will be revealing the card. Okay. Now, what do we have to return? So we have to arrange these cards, correct? That is, these all cards which is present in this integer array, we have to arrange it in a specific order such that once we will reveal those cards by following these order, what we will get is, we will get the card in a sorted order. So if we will sort it, what we will get? We'll get 2, 3, 5, 7, 11, 13 and 17, correct? So it means that we have to come up with a specific ordering of the card. That is, after following these operations on that specific ordering, we should be able to get the card in a sorted order, correct? Now let's see that what is that specific order for these all cards, which will result in revealing the card in an increasing order, okay? So for these all cards, this is the output. Now what does it mean? It means that this is the order on which if we will follow these 3 steps, then we will be able to reveal the card in an increasing order. So let's follow these 3 steps on this output so as to see that are we really getting the cards in an increasing order or not. Okay. So what we have to do, firstly, we have to reveal and remove the top card. Okay. So this is the top card. So what we will do, we will reveal it. So we will get 2 and we will remove it. Correct. After that, what we have to do, after that, we have to place its next card to the end. So what we will do, we'll place this 13 at the end. So we will have it over here. Correct. Now what we have to do, we have to repeat the same step. So what we will do, we'll now reveal this 3. So we'll have 3 over here and we will place this 11 at the end. Correct. Because 11 is the next card to 3. Correct. Now we will reveal this 5 and we will place this 17 at the end. So we will have 17 over here. Now we will reveal this 7 and we will place the next card. That is this 13 at the end. So we'll have 13 over here. Now we will reveal this 11 and we will place its next card. That is the 17 at the end. So we'll have 17 over here. Now we'll reveal this 13 and we will place its next card. That is the 17 at the end. So we'll have 17 over here. Now we have only 17. So what we will do, we'll place this 17. That is, we'll reveal this 17. Correct? Now, what is the order that we got after revealing the card? It's an increasing order, correct? We can see that 3 is greater than 2, 5 is greater than 3, 7 is greater than 5, 11 is greater than 3, 13 is greater than 11, 17 is greater than 13. So after revealing cards of this specific order, what we got? We got that the cards are now in an increasing order. Fine. So it means that this is the correct answer, right? Because after following these all operation on this particular order, we were able to get the cards, or we can say that we were able to reveal the card in an increasing order, correct? Now the question is, how are we going to get this specific order, right? Now tell me one thing, that after performing these all operation on this specific order, we were able to get the deck of cards in a sorted order, right? Now tell me that can we use this sorted array in order to get this order? And you might ask how. So what we can do is we can take this sorted array and we can perform the same set of operation that we performed on this order, right? We'll perform the same set of operation in order to get this order, because when we applied these operations on this order, what we got? We got this, right? So if we will apply the same set of operation on this, can't we get this one? Correct. So let's say, what I mean is, let's say that this specific order is X, okay? And we are getting the sorted array. So let's say this sorted array is S, correct? So what we did is, this is the order which we were having. So on this order, we applied these operations. Let me represent it as operations. Okay. So we applied these operations on X in order to get this sorted array S, correct? Now, can I apply the same set of operation on this S in order to get this X? The answer is yes. And we will be using the same approach. That is, we will be using the sorted form. That is what we will do initially. We will initially sort this deck. Okay. And after sorting this deck, what we will do is we will follow the same set of rules in order to get this specific order. Correct? Now, the question is, which data structure should we use? Correct. So, what are we doing in order to reveal the cards? Let's say these are the cards that we have. Correct. So, what we are doing? We are revealing the first card and we are removing it. Correct. And we are taking the next card and we are placing it at the end. So, what we are doing? If this is a data structure, so what we are doing? We are popping from the front. Correct. Because we are removing from the front. Right. So, we are popping from the front, and what we are doing? We are adding an element at the end. Right. And it means that we are inserting at the end. So, which data structure can we use? Such that we can remove the element from the front and we can add elements from the end. So you might say that we can use a data structure that use FIFO, that is first in, first out, in which the element whichever will come first would be removed first, and whichever will be coming last will be removed at the last. So what we will do is we will make use of Q. Why? Because from Q, what we can do? We can add elements from the end. Correct. And we can remove elements from the front. Correct. Because what was our requirement? Our requirement was that we want to remove from front. Correct. What was our requirement? Remove from front. So can we remove from front in Q? The answer is yes. And what was the second requirement? The second requirement was we want to place this element at the end, right? And what does it mean? It means that insert from end. Correct. Now can we insert from end in Q? The answer is yes. So it means that both of these conditions are holding true in case of Q. So what we will do is we will make use of Q in order to solve this problem. So let's see how we'll be solving it. So what we discussed as of now, we discussed that if this is the output, then what we are doing? If in the output we are applying these three operations, then what we will get? We will get the array in a sorted order, correct? So what we discussed is we will use this sorted array and we will apply the same set of operations in order to get this specific order. So what would be our first step? Our first step will be to sort this deck. So if we will sort this deck, what we will get? We'll get 2, 3, 5, 7, 11, 13 and 17. Correct? What is this? This is sorted order. Fine. Now what we want? We want to apply these set of operation in this sorted array in order to get this result. Correct? And what we discussed is in order to solve this problem, we will be using a Q. Why? Because what is our goal? Our goal is to remove from the top. That is, we want to remove from the front. And in case of Q, we are able to remove from the front, correct? And what we want is, after that, we are placing the next element at the end. What does it mean? It means that we want to insert at the end. And in case of Q, we can insert at the end, okay? So what we will do is, we will make use of a Q. So this is the Q that we will be using, and this is the answer. And what are we going to store in our answer? In our answer, we will be storing that specific order, which will give us the card in increasing order on revealing it by following these steps, correct? And since there are 7 cards in the deck, the size of the answer will also be 7. Fine. Now the question is, what we will be storing in the Q? And why are we actually using a Q? So we will be using a queue in order to know the position of these elements, correct? That is, where should we place this 2 in this answer? And where should we place this 3 in this answer? Similarly, where should we place the rest of the cards in this answer? So in order to know the position, we will be using a queue. So since I am talking about position, so what should we store in the queue? We should store the indices, right? So what we will store? We will store the indices and the queue. So since we have 7 elements, so we will store 6 of the indices. So we'll have 0, 1, 2, 3, 4, 5, 6. Okay. And initially we are present over here, that is at this element. Fine. Now what we will do? Now this 0 represents that this 2 should be placed at the 0th index of the answer. So what we will do? We will place this 2 in the 0th index. So if we'll place this 2 over here, since we have placed this 2, what we will do? We'll move our pointer ahead. So our pointer will now point at 3. And what was the step? The step was to reveal and remove the top card. Correct. So since we place this 2 over here, so what we will do? We will remove this 0th index. Correct. And what was the second step? The second step was to place its next card at the end. So what we will do? We will take this one and we will place it at the end. So we will have 1 over here and we remove this 1 from over here. Correct. Now this 2 is the top element of our queue. Correct. And what does this 2 represent? This 2 represent that this element 3 should be placed at the second index in the answer. So let's place this 3 at the second index. And since we have placed this 3, what we will do is we will move our pointer ahead. And since we place this 3 at the second position, what we will do? We will remove this position. And what was the next step? The next step was to place its next card to the end, right? So what we will do is we will place this next position at the end. So this 3 will move over here. So we'll have 3 over here and we'll remove it. Now what is the top element? The top element is 4. Now what does this 4 represent? This 4 represent that this 5 should be placed at the 4th index. So let's place this 5 at the 4th index of answer. So we will have 5 over here. Since we have placed this 5, we'll move to the next element and we will remove this position. Why? Because we have filled this position, right? We have filled 5 at the 4th position. So we'll remove this position. And after that, what we want to do? We want to place this next card to the end, right? So we will place this next position at the end. So we will have 5 over here, correct? Now, this 6 is the top element. So what does this 6 indicate? This 6 indicates that this 7 should be placed at the 6th index in the answer. So let's place this 7 at the 6th index. So we'll have 7 over here. Since we have placed this 7, we'll move to the next element. That is, we'll move to 11. And since we have filled the 6th position, what we will do? We will remove it, correct? And after that, what we have to do? After that, we have to place its next position at the end. So we will place this 1 at the end. So what is the top value now? The top value is 3, correct? And what does this 3 indicate? This 3 indicates that this 11 should be placed at the 3rd index. But let's wait for now, correct? As of now, what is the answer? As of now, we have this in our answer. Now you might ask me that why are we leaving these spaces in between, correct? And let us verify that as of now is our answer correct. Fine. So what was the rule in order to reveal the card? So if this is a specific order that we will return as the answer, then what will be the rule in order to reveal the card? The first rule was to reveal the card and remove it, correct? So what is the first card? The first card is 2. So what we will do is we will reveal it and we will remove it. After that, what we will do? After that, we'll place its next card. So let's say we have a card over here and what we will do is we will place it at the end. So we'll have it over here, correct? Now what we will do? Now we will reveal this 3 and we will remove it. After that, what we will do? After that, we'll place its next card at the end. So we'll have that over here, correct? After that, we'll reveal this 5, we'll remove it and we will place the card next to it at the end. That is, it will come over here. And then we will reveal the 7 and we'll remove it and whatever its next card would be, we'll place it at the end, correct? So let's see that as of now, are we getting the cards in an increasing order? So we can see that 3 is greater than 2, 5 is greater than 3, 7 is greater than 5, correct? So as of now, we were able to get the card in increasing order. So what does it mean? It means that we are going in the right way, correct? And I hope you were able to understand that why these all positions are empty and why I have not written 3 over here. Because if I would have written 3 over here, then what would have happened? We would have revealed this 2 and we would have placed this 3 at the end, correct? That's the reason why these places are empty. The alternative places are empty as of now. Correct? So let's now get back to the dry run in order to fill this empty spaces. So we were over here, that is at the element 11. And where should we place this element 11? We should place it at the 3rd index. So we'll place this 11 at the 3rd index. And since we have placed this 11, what we will do? We'll move to the next element 13. And since this third position has been filled, what we will do? We will remove it and we will place its next element at the end. Why? Because we are following these steps, correct? Now, what is the top element? Now the top element is 1, correct? And what does it represent? It represents that this 13 should be placed at this 1th index. So let's place the 13 at the 1th index. So we will have 13 over here. And since we have placed this 13, what we will do? We'll move to the next element. And since this 1th position was occupied, we will remove it. And what we will do? We will place its next element at the end. So we will have 5 over here, correct? Now our top element is 5 and it represents that this 11th should be placed at the 5th index. So let's place this 11th at the 5th index. So we will have 11 over here and our pointer will move forward. Now we can see that we have completely processed all the elements of this sorted array, correct? Now, what does it mean? It means that we were successfully able to get our answer, correct? Because we can also see that our queue is also empty, right? So it means that we have successfully filled all the positions of our answer. Fine. And what is the answer? Our answer is this. And we can see that we are getting the same output, correct? That is 2, 13, 3, 2, 13, 3, 11, 5, 17, 7, 11, 5, 17, 7. That is, we are getting our answer. So let's quickly do a recap of what we are doing. Initially, what we will do, we will sort the deck. Why are we sorting the deck? Because we know that if we will apply these all operation in this output, then what we are getting? We are getting the sorted deck, correct? So what we can do is we can apply the same set of operation in the sorted deck in order to get the output, that is in order to get the specific order, correct? So for that particular reason, what we are doing, we are initially sorting the deck, correct? Now, after sorting the deck, what we decided? We decided that we will be using queue. Why? Because using queue, what we can do? We can remove from the front and we can insert from the end, correct? And for what purpose we are actually using the queue? We are actually using the queue in order to know that at which position, which element do we have to insert in our answer, correct? And in our queue, what we will be doing is we will be following these 3 steps, correct? That is, we will place an element and we will remove it, and after that we will place its next element at the end. And the moment our pointer will point at the last index or the moment our queue will become empty, what it indicate that we have got our answer. So I hope the approach is clear to you all. So let's quickly code it. So what is our step 1? Our first step is to sort the deck, correct? Because what we were doing, we discussed that since from this particular order we were able to get the sorted array, so what we will do, we will apply the same operation on the sorted array in order to get this specific order, right? So what we will do, we will firstly sort this deck, correct? So we will say sort deck.begin, comma, deck.end, correct? Now, once we have sorted this deck, what we have to do in our step 2 is we have to populate our queue. And what are we supposed to insert in our queue? What we were storing in this queue over here? Over here, we were storing all the indices in the queue, right? Because we were using this queue in order to know that where to place these all values, correct? So what we will store in the queue, we will store the position, that is the indices, right? So we will create a queue, let's say queue, and let's name it as container. Now let's insert all the indices in it. So we'll say index equals to 0, index less than deck.size, index plus plus. So what we will do, we'll say container dot push index, correct? Now once we have populated the queue, what we have to do, like we have to apply these all operations on the queue in order to populate our answer. So what we will do in the step 3, in the step 3, we will populate the answer by applying rules to the queue, correct? So what we will do, let's iterate over the sorted deck. So we'll say I equals to 0, I less than deck.size, I plus plus, correct? Now tell me, what does the first element of the queue represent? The first element of the queue represent that at which position should I place this to, correct? That is, it represents that at which index in answer should I place this to. So what we will do, we'll take the first element of the queue. So we'll say container dot front. So it will give us the top value of the queue. And what we will do is in the answer of index, what we have to add, in the answer of index, we have to add this deck of I, correct? Because what we were doing over here, we were taking this 0th index and we were adding this 2 at the 0th index of answer, correct? That is, we added this 2 over here. So what we are doing, we are adding in answer of 0, deck of 0, correct? So we did the same thing, that is in answer of index, add deck of I, correct? And once we have populated this position, what we have to do, we have to remove this position from our queue. So what we will do, we'll say container dot pop, correct? Now, once we have done this, what we have to do, we have to follow the second step. That is, we will place the next position of the queue at the end. Correct? That is, say for example, if this is the next position, that what we are doing, we are placing it at the end, right? But before that, what we have to check? We have to check that our queue should not be empty, right? So we will say that if our container is not empty, then what we will do? We will take the next index. Correct? We will take next index. And what is the next index? The next index would be the front value of our container. Why? Because this index was the front value and we popped it out. Correct? So at this moment, what would be our next index? Our next index would be the top value of our queue. Correct? So we will take this next index, and what we have to do, we have to add this next index at the end of the queue. Correct? So we will say container.push this next index. Correct? And since we have placed this next index at the end of the queue, what we have to do, we have to remove this from the front of the queue. Correct? So we will say container.pop. Correct? So what did we did? We added this next index at the end and we removed it from the front. Correct? And the moment we'll come out of this for loop, what we will get? We'll get the answer and we will return it. But before that, over here, we also have to declare this answer, right? So we have to say that answer would be of type int. And what would be its size? Its size would be same as the size of this deck. Correct? Now let's run this. So it's giving us the correct answer. Let's submit it, and it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the given array deck, then the total time complexity would be order of n log n. Let's see how. So what we are doing over here? Over here, we are sorting this given array deck, correct? And this sorting cost us a time complexity of order of n log n, correct? So this is going to cost us a time complexity of order of n log n. Initially, what we are doing over here? Over here, we are iterating over all the n number of indices in order to push it in. Here, we will be iterating over all the n indices. Fine. And over here, what are we doing? Over here, we are populating our answer by iterating over all the n elements of this deck. Correct. So it means that this for loop is also going to cost us a time complexity of order of n, right? So order of n plus order of n plus order of n log n, and we will ultimately get our time complexity as order of n log n. Why? Because we'll get order of n log n plus order of 2n, correct? Since this n log n is comparatively greater than n, so we will ultimately get the time complexity as order of n log n, right? And we are using a queue, which is costing us a space complexity of order of n. Why? Because in the queue, we will be inserting all the n indices, right? So it is going to cost us a space complexity of order of n. One more thing is there to note, that we are using this sort function, and behind the scene, it takes some sort of space as well, right? Like in case of C++, it takes a space of log n. So we will get log n plus order of n as the space complexity. Since order of n is greater than log n, so our ultimately space complexity will become order of n, correct? So that's all about today's daily LeetCode challenge. Thank you.